take a look at this problem. We got 1 minus tangent to the 4th power over secant squared equals 1 minus tangent squared. Well, the hardest side to me looks like the left side, so I'm going to start on that. And right away I see I have an issue. 1 minus tangent to the 4th. I don't have a identity that has the 4th power in it. But then I notice that I got two items and there's a minus between them. Well, remember your difference two squares? We'd have x squared minus 9. You'd try to rewrite it as something squared minus something else squared. X times x would give you x squared. 3 times 3 would give you 9. And then the difference two squares, you could rewrite it as x plus 3 times x minus 3. Well, let's see if that helps us any. We got 1 minus tangent to the 4th power. So let's do the same thing. We'll try to rewrite it as something squared minus something else squared. Now 1 times 1 gives you 1, and tangent squared times tangent squared gives you tangent to the 4th. So we were able to rewrite it as something squared minus something else squared. So I'll take what's in my first set of parentheses, I add what's in my second. And I'll take what's in my first set and I subtract what's in my second. So I can rewrite this top part as 1 plus tangent squared and then 1 minus tangent squared all over secant squared. Now it may seem like, well, boy, he hasn't helped it any. He's made it more complex. But look at what's on the right side. This is where we want to get. We want to get 1 minus tangent squared. Well, here's a 1 minus tangent squared. So probably these are going to cancel away. Now let's take a look at our Pythagorean identities. Our basic one, this is the one I got memorized. Sine squared plus cosine squared is equal to 1. Now I can divide everything here by cosine squared. Sine squared divided by cosine squared gives me tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared gives us secant squared. Okay, now that's looking pretty promising now. Here's 1 plus tangent squared, which is the same as 1 tangent squared plus 1. So I can replace this with secant squared. And everything else remains. Now, of course, the reason why we do that is you see that now the secant squared is going to cancel. And we're left with 1 minus tangent squared, which is equal to the other side, which is what we're wanting to do. Now, all of this is your answer. Now, while we cannot touch the right side, if we're working with the left side, we cannot touch the right side at all. Doesn't mean we can't look at it to see where we're headed, and that kind of maybe give you some hints. Like here, 1 minus tangent squared, I knew this is what I wanted, so this must cancel away then.